Japan shocked by the arrival of America's P-51 Mustang, a fighter aircraft that would soon redefine the nature of aerial combat over the vast expanses of the Pacific theater during World War II, where once the Mitsubishi A6M0 reigned supreme with an almost unchallenged dominance. The early 1940s bore witness to the Zero's supremacy, a machine renowned not only for its exceptional agility but also for its remarkable operational range, which granted the Imperial Japanese Navy the tactical flexibility to project their power across vast island chains and oceanic distances, effectively shaping the initial years of the conflict in the Pacific. Japanese fighter squadron leaders, confident in the Zero's superior dogfighting capabilities, executed tactics that exploited the aircraft's lightweight design, enabling tight turns and rapid climbs, advantages that consistently outmatched the relatively heavier and less maneuverable Allied fighters. This early dominance was underpinned by an operational doctrine that emphasized offensive aggression and pilot initiative, capitalizing on the Zero's ability to engage enemies decisively before they could mount effective countermeasures. The Pacific skies echoed with the roar of these nimble fighters as they patrolled the airspace above strategic islands, enforcing a sense of aerial invincibility that emboldened Japanese commanders and pilots alike. Yet, this era of Japanese aerial ascendancy was abruptly challenged with the introduction of the P-51 Mustang, an American fighter whose design and capabilities heralded a paradigm shift in the balance of air power. The Mustang emerged not merely as a counterpart to the Zero, but as a technological response tailored to negate the Zero's previously unassailable advantages. American pilots, initially cautious and respectful of the Zero's reputed prowess, soon found themselves equipped with an aircraft that combined speed, armor, and firepower in a manner that the Japanese forces had not anticipated. The Mustang's arrival was not a mere incremental improvement but a leap forward in fighter design, featuring a robust airframe and the integration of the Rolls-Royce Merlin engine, which endowed it with unprecedented speed and high-altitude performance. This combination proved critical in the Pacific, where engagements often spanned vast distances and varied altitudes, demanding versatility and endurance from fighter aircraft. The Mustang's extended range enabled it to escort bomber formations deep into enemy-held territories, a capability that directly threatened the Japanese defensive perimeter and undermined the tactical sanctuaries that the Zero had previously patrolled without contest. Strategically, the significance of air superiority in the Pacific War cannot be overstated, as control of the skies was an indispensable prerequisite for the success of the United States island-hopping campaigns, which aimed to progressively erode Japanese territorial gains and establish forward bases for subsequent operations. Commanders on both sides understood that dominance in aerial engagements would translate into the ability to protect naval and ground forces, interdict enemy supply lines, and conduct reconnaissance critical to operational planning. The P-51 Mustang, therefore, was not only a weapon of tactical advantage but also a linchpin in the broader strategic calculus of the Pacific conflict. Its capacity to neutralize the Zero's threat enabled American forces to conduct bombing raids with reduced risk, thereby accelerating the attrition of Japanese industrial and military infrastructure. This shift in air power dynamics forced Imperial Japanese Navy commanders to confront a grim reality. The once feared Zero fighters were now outclassed by an adversary that combined superior technology with the industrial capacity to produce these advanced aircraft in overwhelming numbers. The transition from the Zero's dominance to the Mustang's ascendancy was marked by intense aerial engagements that vividly illustrated the changing tides of war. Japanese pilots, initially dismissive of the Mustang's threat, quickly learned that the aircraft's speed and firepower demanded revised tactics, as traditional dogfighting maneuvers that had exploited the Zero's agility were rendered ineffective against the Mustang's ability to dictate the terms of engagement. Radio communications during these aerial battles reveal the tactical adjustments made by American pilots, who often coordinated attacks emphasizing boom and zoom tactics, diving from superior altitude to strike and then climbing back to safety, thereby avoiding prolonged turning engagements where the Zero's maneuverability was an advantage. Squadron leaders would issue commands such as, "A Mustangs, maintain altitude advantage, engage only on our terms," underscoring the shift from reactive dogfighting to proactive energy management and positional superiority. Conversely, Japanese pilots expressed frustration over diminishing opportunities to leverage their aircraft's traditional strengths, with intercepted communications lamenting, "The enemy Mustangs too fast, cannot hold them in turning fight." These exchanges encapsulate the profound tactical evolution driven by the Mustang's capabilities. Moreover, the psychological impact on Japanese pilots was profound, as the once venerated Zero no longer guaranteed survival or victory. The Mustang's formidable armament, which included 6.50 caliber M2 Browning machine guns, provided American pilots with the firepower to inflict devastating damage quickly, exploiting the Zero's vulnerabilities such as the lack of armor and absence of self-sealing fuel tanks. These technical deficiencies made the Zero particularly susceptible to catching fire or suffering critical damage from even brief bursts of Mustang gunfire, an exploitation that American pilots learned to maximize through their training and tactical doctrine. The Mustang's rugged construction also meant that it could absorb damage that would have grounded or destroyed lighter fighters, allowing American pilots to press attacks with greater confidence and resilience. This combination of offensive and defensive advantages slowly eroded Japanese air superiority, signaling a turning point in the aerial war over the Pacific. Simultaneously, the Mustang's deployment reflected the extraordinary industrial mobilization capabilities of the United States, which was able to produce these advanced fighters in large quantities and deploy them rapidly to the Pacific front. This industrial scale was a decisive factor in the shifting balance of power, as it ensured a continuous flow of fresh aircraft to replace losses and maintain pressure on Japanese forces. The Mustang's presence in the Pacific was not limited to isolated squadrons but expanded to become a core component of the U.S. Army Air Force's strategy, escorting B-29 Superfortress bombers on long-range missions and providing crucial air cover during amphibious assaults. This extended operational reach, combined with the Mustang's performance, allowed American forces to penetrate previously inaccessible areas, further undermining Japanese defensive strategies and contributing to the overall momentum of the Allied advance. In essence, the introduction of the P-51 Mustang marked a decisive shift in the aerial warfare dynamics of the Pacific theater. Where the Japanese Zero had once exemplified air superiority through its nimbleness and extended operational range, the Mustang supplanted it by combining technological innovation with tactical adaptability and industrial might. The Mustang's impact was immediate and profound, challenging established fighter tactics and forcing a reassessment of Japanese aerial doctrine. The shift in air superiority facilitated American strategic objectives, enabling more effective bombing campaigns, securing vital supply lines, and supporting ground operations essential to the island-hopping strategy. This transformation in the skies presaged the eventual decline of Japanese air power and underscored the critical importance of technological advancement and production capacity in modern warfare, themes that would resonate through the remainder of the Pacific conflict and beyond. The development of the P-51 Mustang stands as a testament to American ingenuity and the collaborative spirit that defined wartime innovation, wherein engineers at North American Aviation, confronted with the pressing need for a long-range escort fighter capable of challenging Axis air power, embarked upon a design process that would culminate in one of World War II's most iconic aircraft. Initially conceived to meet the Royal Air Force's specifications, the Mustang's early iterations were powered by the Allison V1710 engine, which, while adequate at lower altitudes, fell short in delivering the high-altitude performance critical to escorting bombers deep into enemy territory. The transformative breakthrough arrived with the integration of the British Rolls-Royce Merlin engine, a powerplant renowned for its superior high-altitude capabilities, which North American Aviation adapted to fit the Mustang's airframe, thereby producing a fighter that married aerodynamic efficiency with unprecedented propulsion. This engineering leap not only enhanced the Mustang's top speed and climb rate but also extended its operational ceiling, granting American pilots the ability to engage enemy fighters on more favorable terms and to escort strategic bombing missions with greater efficacy. The design philosophy underpinning the P-51 Mustang emphasized a balance between speed, maneuverability, durability, and pilot protection, reflecting lessons learned from earlier combat experiences and recognizing the necessity for an aircraft that could sustain prolonged operations over the immense distances characteristic of the Pacific theater. The Mustang's laminar flow wing design reduced drag and contributed to its exceptional speed, while the inclusion of armor plating and a self-sealing fuel tank system addressed vulnerabilities that had plagued earlier fighters, such as the Japanese Zero, which lacked these critical survivability features. The cockpit was engineered to provide the pilot with enhanced visibility and ergonomics, facilitating situational awareness during the chaos of aerial engagements. These design choices coalesced into an aircraft that not only excelled in performance metrics but also afforded its pilots a tangible sense of security and confidence, factors that directly influenced combat effectiveness. Mass production of the P-51 Mustang exemplified the industrial might of the United States during the war, as factories across the nation mobilized to produce thousands of these fighters with remarkable speed and efficiency. The assembly lines epitomized the synergy of engineering precision and manufacturing scale, with standardized components and streamlined workflows enabling rapid output without sacrificing quality. This industrial capacity ensured a steady supply of Mustangs to multiple theaters of war, including the Pacific, where their deployment had profound tactical and strategic ramifications. The ability to replace losses swiftly and to equip new squadrons with advanced fighters bolstered American air power and maintained relentless pressure on Japanese forces. The Mustang's range, extending beyond 1,600 miles with external fuel tanks, allowed it to escort heavy bombers such as the B-29 Superfortress on long-range missions that were previously untenable, thereby extending the reach of Allied air operations and enhancing the protection of vulnerable bomber formations. Tactically, the P-51 Mustang revolutionized air combat, enabling American pilots to exploit a combination of speed, firepower, and survivability that outmatched their Japanese counterparts flying the Zero. The Mustang's 6.50 caliber M2 Browning machine guns delivered a concentrated and sustained volume of fire, capable of inflicting critical damage quickly, while its aerodynamic design permitted rapid acceleration and high-speed dives, tactics that American pilots used to great advantage in the classic boom and zoom combat style. This approach involved diving from a superior altitude to deliver a swift, powerful attack before using the aircraft's superior speed to disengage and reposition for subsequent strikes, thereby avoiding the slow, turning dogfights where the Zero's maneuverability excelled. Radio transmissions from combat missions corroborate the effectiveness of these tactics, with squadron leaders directing pilots to use altitude and speed to your advantage, avoid turning engagements, encapsulating the tactical doctrine that emerged from the Mustang's capabilities. The rugged construction of the Mustang also meant the pilots could absorb enemy fire and maintain operational control, a stark contrast to the fragile composition of the Zero, whose lack of armor and fuel tank protection made it vulnerable to catastrophic damage even from glancing hits. Detailed accounts of key dogfights further illuminate the Mustang's impact on our combat dynamics. In one notable engagement, American pilots described how their aircraft's speed and armament allowed them to break through Japanese formations, delivering precise bursts of fire that ignited Zero fighters and forced others into retreat. These encounters revealed the Mustang's ability not only to defend bomber formations but also to seize the initiative in offensive operations, shifting the psychological momentum in favor of American pilots. The improved survivability and offensive capacity fostered aggressive tactics that exploited the Zero's weaknesses, emphasizing coordinated squadron maneuvers and disciplined energy management. This tactical evolution was instrumental in eroding the Zero's aura of invincibility and contributed directly to the restoration of our superiority over contested regions. The Mustang's deployment also influenced pilot training and squadron tactics, as the U.S. Army Air Forces adapted their programs to maximize the aircraft's strengths. Emphasis was placed on teaching pilots the principles of energy fighting, situational awareness, and coordinated squadron tactics that leveraged the Mustang's speed and firepower. Training scenarios simulated engagements with agile opponents, preparing pilots to resist the instinct to engage in turning dogfights and instead employ hit-and-run tactics aligned with the Mustang's design. This doctrinal shift represented a broader recognition within the American military establishment of the changing nature of air combat and the necessity to evolve tactics in concert with technological advancements. The result was a generation of pilots who not only flew superior aircraft but also operated within a tactical framework that maximized their chances of survival and victory. Furthermore, the Mustang's production and deployment underscored the strategic integration of American industrial capacity into the broader war effort, demonstrating how advances in design were matched by the ability to field these aircraft in overwhelming numbers. The logistical feat of supplying parts, maintenance, and pilot training across the Pacific theater was a crucial enabler of sustained Mustang operations. This industrial and logistical synergy ensured that the Mustang's technological advantages translated into operational dominance, with American forces able to maintain continuous pressure on Japanese units and deny them the opportunity to recover or regroup. The Mustang thus became not only a symbol of American technological prowess but also an embodiment of the nation's capacity to mobilize resources effectively in the pursuit of strategic objectives. In sum, the P-51 Mustang's development and deployment constituted a pivotal chapter in the air war over the Pacific, wherein a combination of engineering innovation, industrial might, and tactical adaptation converged to produce a fighter aircraft that decisively altered the course of aerial engagements. The Mustang's superior speed, range, firepower, and durability challenged the previously uncontested dominance of the Japanese Zero, forcing a re-evaluation of fighter tactics and contributing to a broader shift in the strategic balance of power. Its ability to escort bombers deep into enemy territory and to engage enemy fighters on favorable terms provided American pilots with a critical edge that accelerated the erosion of Japanese air capabilities. This synthesis of design excellence and tactical effectiveness ensured that the Mustang would not only play a central role in the Pacific conflict but also leave a lasting legacy in the annals of military aviation history. Despite the Mitsubishi A6M0's early reputation for unmatched agility and range, a detailed examination reveals significant limitations that ultimately undermined its effectiveness against the technologically advanced P-51 Mustang, a disparity that profoundly influenced the aerial conflict in the Pacific theater and reshaped the strategic landscape. The Zero's design philosophy, centered on lightweight construction to maximize maneuverability and fuel efficiency, came at the expense of critical defensive features such as armor plating and self-sealing fuel tanks, vulnerabilities that proved fatal when confronted by the Mustang's superior firepower and ruggedness. Whereas the Zero could outmaneuver many Allied fighters in slow speed, turning dogfights, it was ill-equipped to withstand the concentrated bursts from the Mustang's 6.50 caliber machine guns, which, combined with the Mustang's ability to engage from advantageous altitudes and speeds, exposed the Zero's fragility. These design trade-offs, once beneficial in the early stages of the war, became liabilities as American pilots exploited the Mustang's strengths, transitioning from defensive evasion to aggressive engagement strategies that targeted the Zero's structural weaknesses. The absence of self-sealing fuel tanks in the Zero notably increased its susceptibility to catastrophic fires, a vulnerability that American pilots quickly learned to exploit through tactical innovations such as high-speed diving attacks and coordinated squadron assaults. Unlike the P-51 Mustang, which incorporated these protective measures to enhance pilot survivability and aircraft endurance, the Zero's fuel system was prone to ignition when struck, leading to rapid loss of aircraft and crew during engagements. The lack of armor protection further exacerbated this issue, as Japanese designers prioritized weight reduction over pilot safety, resulting in aircraft that, while nimble, could not absorb significant enemy fire. The Mustang's robust construction, conversely, enabled it to sustain damage and remain operational, shifting the psychological balance in dogfights and emboldening American pilots to press attacks with greater confidence. This fundamental disparity in survivability manifested repeatedly in combat reports, with American pilots recounting instances where their Mustangs, though hit, remained controllable, whereas Zero fighters succumbed swiftly to even moderate fire. Tactically, these limitations forced Japanese commanders to reconsider fighter deployment and engagement doctrines, as the Zero's initial advantages in maneuverability were neutralized by the Mustang's superior speed, altitude performance, and firepower. The traditional Japanese emphasis on close-range dogfighting and pilot initiative became increasingly untenable as the Mustang's boom-and-zoom tactics, characterized by diving attacks from altitude followed by rapid disengagement, exploited the Zero's sluggish acceleration and lack of armor. Radio intercepts from Japanese units reveal growing frustration and tactical confusion, with pilots expressing concerns over their inability to match the Mustang's energy management and firepower, encapsulated in communications such as, "We cannot hold them in turning fight, too fast, too strong." This erosion of tactical confidence translated into diminished effectiveness in air engagements and contributed to rising attrition rates among Japanese fighter units, compounding the strategic challenges facing Imperial Japan. The consequences of this shift in air superiority extended beyond isolated dogfights to influence the broader trajectory of the Pacific War. Control of the skies was a prerequisite for successful amphibious assaults, naval operations, and the protection of supply lines critical to sustaining frontline forces. The Mustang's dominance severely curtailed the operational freedom of Japanese air units, restricting their ability to contest Allied bombing raids and reconnaissance missions. This, in turn, facilitated the progressive degradation of Japanese industrial and military infrastructure, as American bombers penetrated deeper into enemy-held territories with reduced losses. The psychological impact on Japanese forces was profound, as the once feared Zero fighters lost their aura of invincibility, undermining morale and contributing to the gradual collapse of Japan's defensive perimeter. The Mustang's strategic implications thus extended far beyond the cockpit, shaping the operational environment in which ground and naval forces conducted their campaigns and accelerating the Allied advance across the Pacific. Post-war evaluation cemented the P-51 Mustang's legacy as one of the most effective and influential fighter aircraft of World War II, a status earned through its combination of technological innovation, tactical versatility, and the ability to be produced and deployed at scale. The Mustang's design principles informed subsequent generations of fighter aircraft, emphasizing the importance of balancing speed, range, firepower, and pilot protection, a synthesis that became foundational in modern air combat doctrine. Veterans and historians alike have lauded the Mustang not only for its combat record, but also for its symbolic representation of American industrial capacity and strategic foresight. Personal testimonies from pilots who flew the Mustang recall the confidence it inspired, with one veteran stating, "Flying the Mustang, you knew you had the edge, it was a machine built to win." This sentiment reflects the broader narrative of the Mustang as an embodiment of Allied technological and tactical superiority, a key factor in securing victory in the Pacific. The Mustang's enduring influence is evident in the way it reshaped air combat tactics and aircraft design philosophies in the post-war era, setting standards for speed, range, and survivability that would guide the development of jet fighters and beyond. Its success underscored the critical importance of integrating technological innovation with pilot training and tactical doctrine, lessons that have reverberated through subsequent conflicts and continue to inform military aviation strategy. The aircraft's role in undermining the capabilities of the Japanese Zero and securing air superiority contributed decisively to the Allied victory in the Pacific, demonstrating how advancements in technology and industrial capacity can decisively alter the course of warfare. Thus, the P-51 Mustang remains not only a historical artifact but a symbol of the transformative power of innovation and adaptation in the crucible of combat.